With that being said, I'd like to go ahead and introduce myself. My name is Michael Corey, and I am a consultant at the Educational Service Center of Northeast Ohio. And I am excited to spend the next hour or so with you today. I'm certainly glad you could join us. I know you have a lot of things on your plate. You're wrapping up the school year. If you are done with the last school year, I want to congratulate you on that. I know there's still a lot of work to be done over the summer in preparation for next school year. And I hope you get an opportunity to relax a little bit from which is certainly a very hectic past few months. So that being said, I want to welcome you to Mathematical Discourse. We started off with a chat box question, what is mathematical discourse? And it's now buried in the chat. So you'll have to kind of scroll up to see some of the responses, but there's some really great ideas that are showing up there. One of those big ideas that keeps popping up is the idea of conversation. We're talking about vocabulary, we're talking about language, and all of those elements are woven together. Now, typically, what I do for mathematical discourse would be a day-long training. We would work through examples. I would have you engage in a lot of math discourse. I would have activities. In this Zoom session, in this hour-long session, I'm really just going to be able to hit those highlights. But I will share with you a lot of resources that you'll be able to take with you. And of course, everything I'm going to be talking about today, I'm going to try and give a little bit of flavor what something would look like in a physical classroom, brick and mortar, but also how you might use that in a blended classroom or digital scenario, because we simply don't know what next year is going to look like. There's still a lot of question marks there, and I want you to be prepared. And a lot of these things you'll be able to plug and play. Whether it's in an online setting or an in-person setting, there are certainly some challenges that exist with both of those scenarios, but we can still make some headway when it comes to math discourse. So with that being said, I'm going to go ahead and move forward here. So like I said, my name is Michael Corey, and just because of our hour-long session today, I have a lot of content for you. Again, just hitting some highlights. I really wish I could go into a lot of detail, but if you do have more questions, or if there's something I said that you'd like to have elaborated on, or a question, or whatever the case might be, I'll be sticking around after we're done here. And if you'd like to hang on after 11 o'clock, I'm more than happy to stay on as long as you would like to answer any questions that you might have. Oh, additionally, I almost forgot to mention, at the conclusion of this session, you will be receiving the slide deck, as well as a recording of this session and a transcript of the chat. And we do that so that way you have reference back to a lot of the resources, a lot of things, because I'm sharing my screen with you, you can't access them live, but in my slide deck, I have a lot of links that I'll share with you. So when we send you the slide deck, you'll be able to click and explore and check out those resources. So you'll have that. You just don't have it right now. You'll have that sometime later this afternoon or tomorrow. Also, the recording of this video and also a transcript in the chat. So if you have resources, or if you have an idea, or somebody said something in the chat that you'd like to refer back to, you'll have a transcript of that chat you can look at as well. So with that being said, we will move forward. And I want to take a quick poll just so I know who my audience is. What building, what grade levels do you serve? And I'm talking you as an individual, not your whole building, but what grade levels are you currently teaching in, or what bands? Give me an idea as far as who my audience is. So there's certainly a lot of application that we can make with math discourse regardless of the age. I have a few videos to show you, just some very short clips that show some at the primary level, some at the middle and high school level. So you'll certainly have some examples at either end. But as I'm beginning to kind of, if I throw out an example on the fly, it gives me a good sense. I'm going to go ahead and shut down the poll. And it is anonymous, so I mean, not that it's really a secret, but I don't know who is who. I'll share the results so you know. You can see about a third of the room is high school. We have, it looks like a handful of folks at the middle or intermediate level, and more folks at the early grades, primary level, and a few district level folks as well. And that district level could be a number of things. It could be administrator, it could be some math coach, it could be, any number of things. But it gives me a sense as far as who's in the room, so I appreciate you doing that. Okay, so also I just ask that you bear with me. I'm trying to manage the chat and the presentation at the same time. So if you ask a question and I don't answer it right away, please just be patient with me. I'll get back to it. If I don't answer it verbally, feel free to ask it again, or and I'll go through the chat. If there are any questions I didn't answer, I'll certainly follow up with you either at the end or I can send you an email if there's something that you mentioned in the chat that I don't get to. So just bear with me on that. Today's session outcome. So today, the purpose of our time together, and again, it's going to be more of a highlight scenario. We're not going to get into super depth with any one topic, but it's going to be, I hope to give you some idea as far as what math discourse is. Judging by the responses in the chat, it looks like we have a pretty good idea already about what some of those elements are, but more importantly, how do they improve student performance? So we'll talk about that as well. And then finally, probably the most valuable part is, what does math discourse look like in a math classroom? So we'll take a look at some video clips. I hope to give you just a few tools to get you thinking, get you reflecting. Again, we won't be able to develop any tools or things today just because of the nature of our session and the time frame. But in this time, I just hope to give you at least something to get you started and get you thinking and get you resources because you now have a couple of months to prepare and to plan for next school year. And I know a lot of you will be doing that. Okay, so Zoom norms, I'm not going to really just spend a lot of time here. I'm sure you spend a lot of time on some sort of video chat. We always use our camera whenever possible. I see some familiar faces who have been in some of my sessions before. Also, generally like to write your first and last name in your Zoom square, or at least at a minimum your first name, so that way we can have some way to identify each other. I had you muted upon entry. You can unmute yourself. I ask that if you're not speaking, just keep yourself muted. You never know when your 3-year-old son is going to burst into the room and want to show you his camping lantern, which has happened. We had a near catastrophe yesterday, but thankfully that was averted. But background noise, dog barking, just that sort of thing. So just keep your mute on whenever possible. And then, of course, use the chat. Chat is a great place for you to have some interactivity as well as share resources and share ideas with your colleagues. So those elements really are very helpful when we're in this sort of environment. So that being said, let's talk about some content. The first thing I want to talk to you a little bit about is, well, what is discourse? Discourse is one of those words that can have a variety of meanings. And one tremendous resource, and I'm sure you're familiar with it. If you aren't, I would definitely check them out, as NCTM. There's so many resources that it can get overwhelming, but they have a lot of really great research, a lot of great publications they put out. And NCTM, in one of their periodicals, talks about discourse is a mathematical communication that occurs in a classroom. And mathematical communication is really that key phrase. Along with that key phrase, we're also thinking about things like, how do we choose tasks that engage students and challenge all students' thinking in the classroom? How do you encourage students to listen carefully to one another's ideas, to disagree, to question? And oftentimes, the dialogue, the listening is probably just as important, if not more important, than the person sharing the idea. So we'll talk about active listening. How do you decide whether or not to pursue a mathematical idea? How do you help students to clarify or justify their ideas? One of the things that we'll talk about a little bit later is that sometimes students want to participate. The students, they want to be able to say something or explain their thinking, but they don't always have the tools to do that. So how do we as teachers scaffold the conversation? Someone mentioned earlier that discourse is a lot like language. And my wondering is, if we approached teaching math using some of the tools that we use to teach world language, I wonder what benefit we might get from some of those techniques. And so we'll touch on them. We'll talk about that a little bit later this morning. And then finally, teacher to student conversations in the classroom. How do we take those and we turn those into student-to-student conversations where they actually interact with one another in a meaningful way? They're not just talking, they're not just saying, well, I did this and I did this, but there's some more structure to that. I have linked in the presentation. I'm not going to go there now, but I wanted to link In case you were unaware, I see in the chat someone answered it, NCTM, National Council of the Teachers of Mathematics. We have an Ohio affiliate, OCTM, the Ohio Council of Teachers of Mathematics. They do a lot of great professional development in this state. NCTM does some great stuff, but that's of course at the national level. So that could be, I think there's one in Florida. I don't know if it's been canceled or not. I haven't looked. But they also have a set of professional standards for teaching math. And those standards really kind of help to frame the idea, how do I approach discourse from the teaching side? So I have that link there. We're not going to go into that. If this were a day-long session, I would, just to show you some of those ideas. But that's linked there, so that way you can check that out if you're interested. Additionally, discourse is not only just communication, but it's an engagement, it's a countable conversation and collaboration about thinking that cultivates understanding. So again, the ultimate goal of discourse, the goal of engaging in that sort of technique is to get students to understand and learn the math more deeply. So that certainly speaks to student engagement. It also speaks to accountable conversation. Again, this is not two students that are working together on a worksheet. This is more of an in-depth engagement that is linked with the math. So it's more than just talk. The mathematical discourse encourages students to reveal their understanding of math concepts as they engage in that math reasoning and debate. So you as the teacher, as you're listening to the students talk, or if it's person to person, small group, large group, whatever the environment happens to be, you as the teacher can hear what that student's saying, and then because you're the expert in the math, you can pick up on where that student is struggling. And you can pick up on that struggle a little bit different than if the student were just to write the math down. And as you begin to have that experience, and as you begin to look at, when you're grading papers, excuse me, if you're grading assessments or you're looking at student work, I'm willing to bet that you can pick out what errors happened pretty quickly. So those types of errors, those sorts of cognitive struggle that students are dealing with, you can pick out in that discourse, which is why it's so important. And those rich mathematical conversations, and the operative word here is rich, we'll identify that and define that here shortly, that really forces students to become fully involved in all elements of the conversation. That's not just the question and answer phase, it's also the conjecturing, the defining, and explaining. And one of the things we're going to talk about is having tasks where students have the opportunity to develop and be creative and think about solution paths and have differing opinions and views. So when we talk about creating open tasks, which we'll talk about here in a second, it's about creating an environment where there's some diversity of thought. That way, things aren't just limited in scope and there's only one right answer. So in addition, there are the 8 mathematical practices, which is something that is in our standards. And the discourse really hits the nail right on the head. Making sense of problems and persevere in solving them, reason abstractly and quantitatively. And I would be willing to bet that if you're in a scenario where you are writing something down, you have probably said it out loud to yourself before, right? The act of speaking and the act of thinking are connected in a way that writing isn't. So writing's important. Don't get me wrong, but the speaking element and the listening element add something to that puzzle. Also, the idea of constructing a viable argument and critiquing the reasoning of others. One of the things that students oftentimes don't have enough experience with is arguing or making their case or explaining themselves to someone else. Lots of times, I have explained myself I have my argument in my head, why I think what I think, and it makes sense to me, but I haven't identified maybe some areas that don't make very much sense because I understand it. It's only when I begin to have conversation with someone else that I understand, well, wait a minute, maybe that thinking doesn't make as much sense as I thought it did. We also allow students to engage in the critiquing of the reasoning of others. And this can be challenging. Students have to be taught this, and we'll talk about that. They don't know how necessarily to critique one another in a positive and a constructive way right off the bat. This has to be modeled, it has to be demonstrated, and we oftentimes have to provide some serious scaffolds to get students in a place where they can meaningfully provide constructive criticism to their classmates. Not only does the classmate receiving the criticism understand where the gaps in their reasoning reasoning might be, but the student providing that critique has thought about the problem in a way that maybe they hadn't thought when they're just working through it themselves. So when we want to create an environment for some level of discourse, one of the things that we have to think about is what environment are we putting students in to have that discourse? This is something that starts at the beginning of the school year, and this is going to fit right in with whatever your rules are, your classroom expectations, whatever that tone, how you begin off the school year, how you begin to build those relationships with kids. When students are entering the classroom and you're setting the tone, this is the time to set some norms for math discourse. Not that math discourse has to happen, as all period every day, but there should be some level of discourse that's happening on a daily basis, whether it's a small amount, a large amount, or somewhere in between. But those norms are setting the tone for how we have conversations with one another in an academic way. So we want to, of course, practice these good listening skills, right? We look at and we listen to the speaker. We talk about thinking about what the person is saying and being able to respond or ready to respond. Of course, non-negotiables, using respectful language, using academic language. We'll hit on this a little bit later this morning too, and share the air, right? We don't dominate the conversation. We'll talk about for some techniques. You say, Michael, you're telling me that they should look at and listen to the speaker, but I'm telling you, my students right now, they just don't do that. They get upset. They see a squirrel out the window and they're just fixated on that squirrel or whatever. They're talking about a million other things. I understand that. There are some techniques that we can talk about. One of them is having students be ready to respond to their peers and asking them to respond to their peers. So if they are all of a sudden called on, and I say, hey, Johnny, would you reply to what, Susie just said? Well, wait a minute. So we'll find about ways to get students to be, accountable for their listening, which is certainly important. Here are your 8 mathematical practices. I highlighted the 3 of them. I put this slide in here because I always want to mention when we're teaching the standards, and that's what we're doing. We're not taking time away from the standards to do discourse. We're doing the standards through discourse. And the standards talk about what students have to know. The practices talk about how they have to know them. If you look at the standards document from the state of Ohio, starting in kindergarten, going all the way up through geometry, which is the scope the standards cover, you look at all of those elements, those grade levels, all grade levels, but those standards that you are teaching are the what. But students have to know the standards in these ways, right? It's not that I know how to solve a proportion, but I also have to be able to model with it. I have to be able to know when to use it strategically. I have to look for and make use of structure with proportions. I have to be able to reason with. So these practices are applicable in every area, every grade level, every standard. So that's something to keep in mind. Now, when we talk about creating a math mindset, there's a whole separate session training that I do talk about building mathematical mindsets. And it's all based around the question being about, is there such a thing as a math person, right? You hear so many times, well, I'm not a math person. You hear that from parents. Well, I was never a math person, right? Well, I want to identify, say right off the bat, there is no such thing as a math person. There's no math. I'm using a lot of scare quotes. Maybe I'm overdoing that. But, the idea that some people are inherently good at math and some are inherently not good at math, and that there's no research that supports that. But nevertheless, students come to us sometimes with that baggage. So we want to make sure that we're encouraging students and we're saying, hey, look, I think you can learn everything at a high level, regardless of what your past experience has been. Mistakes are valuable. Now, when we say mistakes are valuable, not only should we just say that, but we should follow that with our practice. So do students have an opportunity to do something over again? That's a different conversation for a different day, but it really surrounds this idea of discourse, that it has to be okay for me to be wrong. It has to be okay for me to change my mind. Questions are really, really important. Oftentimes in math, we don't spend enough time developing the question. Too often in math, and this is because I think there's a lot of reliance on textbooks, is that we just tell the students the problem. Here's the problem, solve it. Now there's a time for that, but if that's all we're doing, if we're never developing the question with the students, if we're just saying, hey, there's this person and they have a barrel full of watermelons and they're going to take it to the market and exchange it for a basket full of tangerines, it's an arbitrary problem that you just told the students and they don't have any investment in what that is, and they may not understand Why do we have to solve this? This is something that you just made up. So we have to really focus on questions. Why are questions important, and how much time do we spend developing the question so the answer is meaningful? And math is really about creativity and making sense. But again, it's one thing to talk that talk, but we have to follow that up with what we're doing. So in math discourse, one of the key elements is having multiple solution paths and opportunities to explore them and explain them and talk about them with my peers. So that is that creativity. It's also the making sense. But we have to provide space for students to do that, rather than just say that that creativity is important in math. It's certainly about making connections and communicating. And again, I think there's a lot of similarities between learning math and learning language. And depth is more important than speed. And you can accomplish, and as you begin to practice this and try some of these techniques, you'll find that it's about that you can get faster and more efficient with these ideas. And that math is about learning, not performing. So we get to put the emphasis on the learning rather than just what happens on the summative assessment. So discourse helps to build that mentality. So a couple of things I'd want you to reflect on kind of while we're working through some of this content is that what we call discourse actions. And this was actually in a very recent periodical from NCTM called Teaching and Learning. Matter of fact, or Learning and Teaching rather. Here I have a copy. I'm a member of NCTM, so this comes in the mail to me. A really great article from Candela, Boston, and Dixon that talk about specific actions that you take when promoting discourse. The first of which is prompting students to explain their answer, strategy, or thinking. So we're asking, okay, tell me more about that. Say more. How did you solve the problem? Why did you multiply here? Not what did you do, right? If you say, what did you do here? That's a closed, fixed response. I multiplied. Instead, why did you do that? So this is you prompting, right? You're listening just for what the student is saying, and you're prompting them to tell you more. Eliciting students to provide justification or math proof. Now, when I say math proof, I don't mean that long, complicated stuff that we did in college. What I'm saying is, what is your reasoning? Prove to me this is true. Again, if we were in person, there's a whole activity I would walk us through, but it's the idea of convincing my neighbor of something. Talk about why you did. Talk about why it makes sense. Why did you choose to multiply here? Why didn't you add? So those sorts of promptings are the beginnings of those conversations that happen in the classroom. Also, asking students to validate math accuracy in their statements, right? So explain, why does this answer make sense? Too often we get to the answer and we just leave, right? Students just say, okay, I solved it, I want to move on. And you're like, well, check your answer, check your answer. Well, it's more than checking your answer. It's explaining why your answer is sensical. How do you know your answer is correct? Is your answer reasonable? Is this the only answer you could come up with? Why do you think that is? And asking other students to contribute as well. Okay, well, this student got this answer, ask another student, hey, does this answer make sense? Why or why not? So these are the beginnings of from a teacher level, prompting that conversation on a large group level. We also talk about linking, teacher linking and content together and student linking content together. So we want to connect teacher to student, but we also want to connect student to student on a horizontal level. So one technique that's pretty effective is asking another student to revoice what someone else has said. Meaning, Timmy, can you tell me what Joel just said? Having students revoice each other and explain. And what that does, it does two things. Number one, it's an active listening technique, right? You're holding students accountable for the active listening. And also, it gives students an opportunity to see where the holes in what they explained might be, right? Because if you tell me how to do something and then I have to turn around and tell someone else, I all of a sudden understand, well, wait a minute, I don't have as much information as I thought I did. So revoicing other students' ideas is a pretty powerful technique. It's relatively non-threatening, and again, we're building that environment, right? So we're modeling this. You're showing them. You're revoicing first, so they can see how it's done, and then slowly you begin to feed that out to the students. We also want students to take up the ideas of their peers, right? Maybe you didn't solve it this way, but this student started down this other path. Even though it's not your solution path, I want you to take this other student's solution path and tell me what the next step should be. So we're engaging students in each other's ideas. So they're required then, but they have to talk to each other about okay, I wasn't thinking about it that way. Why did you start this way? So I know what to do in step 2 because you started this way. And you as a teacher are saying, okay, well, this is a valid solution path, or you're providing the feedback. In the chat, I noticed that Judy asked, can discourse be a formative assessment? And I would say 1,000%. And I say that as a math teacher. I know what 1,000% means. Absolutely, it's a formative assessment. Formative assessments are happening during the learning. Discourse is happening during the learning. Formative assessment is so powerful because it is connected with feedback, right? If you're formatively assessing your students and you're only using that information to adjust your instruction, you're missing out on a piece of formative assessment. It's providing the student the feedback. And if not, the feedback doesn't come just from you. The feedback in discourse comes from the other students sometimes, right? Because if they're talking to one another and what one student said doesn't make very much sense, they're going to get that feedback from the student that they're talking to. You're guiding that, you're scaffolding that, you're monitoring that, but absolutely, it's a tremendous formative assessment technique. And then finally, students are focusing their attention on the student's explanations. So not only are you paying attention to that, so that way you as the teacher know where the student is and what that feedback should be. But the students are paying attention to each other's explanations because they may think about it in a new way. Like, well, how I was doing it. For example, when I was doing a walkthrough in a classroom, there were some students, they were working through some multiplication of 2- and 3-digit numbers. And one student was doing the grouping technique. It was like 13 times 15. There was something along those lines. And the student literally drew 15 groups of 13 dots. And he was just there forever. He was just drawing and drawing and drawing and drawing. That is a solution method. Will it get the answer? Yes, it will get the answer, but it's not efficient, right? And so no wonder that student gets frustrated and they're just tired and they think math is ridiculous because that's the only solution they're stuck in. When their students were working in groups, another student was kind of showing a version of the distributive property where it was 13 times 1, 13 times 5, and so the student was really beginning to think about, and I didn't watch it long enough to see how it turned out, but at least those first few responses from the first student are like, okay, I see what I'm doing is not the best way to approach this. And sometimes that's better coming from another student. I don't know, you know your classes, right? You know how well your students interact with one another. Sometimes hearing something from another student can be very, very powerful. Here are 4 practices that get you started. These are things for you to reflect on over the summer as you're choosing assignments, building units, talking about what projects you're are going to do, especially in a blended environment, right? So when a student is online versus in person, we have to kind of think about these things a little bit different. Sometimes discourse has a little bit more writing or typing involved in a blended learning, or maybe they're recording themselves and they're being verbal with it. Whatever the case might be, these 4 practices are going to apply. The first one is using an open task. What do I mean by open task? We'll define that in a minute. We're going to support thinking and pairing and revoicing or comparing. The third one is we're going to offer 3 different ways to participate. I'll illuminate what those are here in a moment. And then fourth, we're going to talk about, we should define what does a contribution mean. So someone in the chat, Judy asks, how do you adapt practices for students who still don't know their facts, 9th grade, to get them improve their fluency? Great question. Probably not, I can't answer it in its fullness now, but I will say that doing one practice that I'm not sure, I wonder if it has the effect it should have, is things like time tests for math facts. Matter of fact, I have a slide a little bit later that I think is pretty effective for building number fluency. And this is coming from a former high school math teacher. I taught Algebra 1, I taught Geometry, I taught Algebra 2, and I had students that, they come into the algebra classroom and they don't know any of their math facts. And it just slows them down. They get frustrated. So there are some strategies that we can talk about, one of which is going to be later in the slideshow. So when I say use a more open task, what do I mean? So when we talk about using an open task, let me show you a non-example first, right? Find the area and perimeter of a rectangle with a length of 20 feet and a width of 10 feet. Now, I want you to respond in the chat. I want you to think about this for a second. What about this task makes it a non-example? Why is this not? And we haven't really even defined open task yet, but just based on kind of what you're thinking is, what about this task is closed? It's not an open task. All right, there's only one answer, one correct answer. Focus on the answer. It stops at the answer. I really like that, Lisa, right? It stops, right? You get the answer and you are done, right? So those are all right on, right? There's no multiple approaches, really. I mean, you might say, okay, I'm going to, add up the perimeter. I'm going to do the 20s first and then the 10s, but there's no meaningful difference. And there's certainly a level of just, okay, I'm going to apply the formula here. There's no discussion, right? Students are going to work, even if they're just working together. How did you do this? Oh, I did it this way. It's very, very limited in its time frame. Now, if we contrast that with something very similar, it's going to hit the same standard, but it's going to hit it in a different way. We're going to open up the task. You have 60 feet of fencing to build an area for your dog to run and play. What are 3 different sized pens that can be built? What is the area of each pen? What is the area of the largest dog pen that you can build using this fencing? Use a diagram and explain in your words your answers to questions 1 and 2. Now, why is this one different? What about this? And there's a lot of ways that it's different, right? So what about this example is different? Why is this I would say, better task for Discourse? Respond in the chat. We're talking about using different skill sets. Absolutely. A lot of different details, multiple solutions. There's depth of responses. Certainly, they can draw a picture, build a model, use a formula. I love it. There are many answers that are correct. Absolutely. We have different solution paths. They have to use language to interact with one another. One thing that wasn't mentioned, that we've connected this problem with real life, right? The last problem was just some random rectangle. Well, who cares about some random rectangle? But I have a dog, right? And I have a fenced-in yard, so so if we connect it, I mean, there's a little bit more reason to talk about it. And then, of course, when we're talking about using a diagram, explaining now, are we hitting the same standard? That's the question. Are we wasting any time? Are we taking a break from the standard to hit this type of problem as opposed to the last one? And of course we're not, right? This is the same standard. It's hitting the same mathematical idea, but it's doing it from a different direction. It becomes more meaningful. Not only that, in the last example, we don't identify any connection between perimeter and area. In this one, students can begin to see, okay, wait a minute, I now can identify that even though I have the same perimeter, I have different area, right? You could have a very long, skinny pen that's a really super long rectangle with a limited area, right? And then say, okay, why is that bad? Oh, well, because we've connected to our dog, we're like, okay, well, because my dog can't run around. Now, if we take and have a square, which we know is the maximum area, we can say, okay, this is better for the dog. These are the reasons. And I can say, okay, we're spending the same amount of money on the fencing. So there's a lot of different ways we can go with this. And there's a lot of different ways that students can engage in conversation, meaningful conversation. All right, so if we want to talk about making tasks more open, here are some tips to keep in mind when you're planning for this. First, we want to provide students with choices, right? And the last one, it was I identify 3 different rectangles. I didn't give them the rectangles to choose. I wanted them to come up with the rectangles. Secondly, we remove segments of the problem that over-scaffold. Textbooks are notorious for this. Textbooks over-scaffold all the time. They provide way too many details. Oftentimes, you'll have problem sets that look exactly like the sample, right? The sample will have a problem all worked out. It's all color-coded. And then the practice problems look exactly the same way. So a student can be successful in a math classroom without knowing any math and just knowing how to decode a textbook, right? So we can take a problem from the textbook and we can de-scaffold it. So that means take away some of the supports. Not all of them necessarily. You make the judgment call on that. But we can start with what the textbook gives us, but I would just, with caution, use what the textbook provides without any alterations. We want to ask students to just find more than one solution path. And this is a great way for students to interact with one another. That's okay, here's a problem, here's how I solved it, here's another problem, here's how I solved it. Explain it to each other, and then we're going to talk about it as a group. So we open tasks that way by identifying multiple solution paths. It's not about just finding the answer. Asking students to explain their solutions and think about other students' solutions. And I talked about this a little bit before, right? Revoicing one another. And then present the problem in a real world context, right? It's harder to just care about just a plain rectangle, it's easier to make more connections when there's some sort of connection to real life, even though that connection may not be something that that they're going to experience in their real life. It's fine. Students are more engaged when they see something that is authentic, right? I may not be the one who's going to go out there and dig post holes and put a fence in, but I know that that is a thing that happens, and I do care about it because I have a dog. So there's some level of connectivity with the problem. And remember, we talk about one of the math practices is perseverance in problem solving, right? And so when we have these scaffolds, when we open a task up, there's more incentive to persevere rather than just finding a very narrow answer all of the time. One of the other strategies is supporting thinking, pairing, and then revoicing and comparing. So thinking is a solitary task, right? Ask students to think about a problem, write down their solution, their initial thoughts, their initial questions. And I would even recommend at times, they're not even accountable to turn in something for you here at times. Maybe sometimes they are, but have them think. And the reason I say don't have them accountable to turn in something for you, great with this, because again, we value mistakes, right? We value changing our minds when we encounter new information. So we want to encourage that and not hold them accountable for the very first time they thought about something. Also, pairing. So the accountability comes in later when we ask them to revoice their peers. The pairing. So have them pair up with another student. How you pair them is entirely up to you, but have them not only talk about what their solutions were, but give them some structure. Okay, why did you solve it this way? Are there other ways to solve it? Can you think of any problems with your solution method? Why will this work every time? Why or why not? You're providing some level of scaffold for that conversation. And then when students, as they work in pairs, they're ready to begin to think about each other's thinking. So when you come to get back together as a big class, you can then identify, have them explain each other's solutions. They can also identify maybe differences, key differences in the gaps between those two. Well, I thought my solution was a little bit more efficient, or I thought my solution probably won't work every time, and here's why I think that's the case. So we're supporting this collaboration between students. Also, we want to offer at least 3 different ways to participate, right? If we're talking together in a whole class, sometimes students may not they may not be ready to restate or ask a question about what they heard, but they would be willing to restate what they heard in their own words, or they can add on to what somebody else has said. We want to provide choice for students that they're not only just sharing their solution method. Not only would you probably run into time constraints in your class, but we provide, there are different ways to interact, and here are 3 different ways to try that, right? Ask a question, restate what they heard in their own words, and add on to what they heard. Which, by the way, notice each one of these 3 elements is accountable listening, right? Students have to be paying attention in order to ask a question about something, about not a question about the topic in general. I'm asking, I see Donna's right there. Hi, Donna. And if Donna says something and I turn around and say, okay, to another student, what did Donna say? Or ask a question about what Donna said, all of a sudden I'm now going to be embarrassed because I wasn't paying attention. Or, as students will quickly find out, it's better to be and stay engaged. And finally, we need to define a contribution. What does it mean to contribute? Is it a yes, no? Is it just to provide an answer? So this is a really great time for you to show an exemplar or for you to model. This is especially effective if we start this off early in the school year. So students know, and maybe it's a video clip, students know what it means to meaningfully participate. And so that way they have some way to structure their responses. So here's an example of a great task. This is probably a task for middle school, maybe 9th grade, depending on the level. So the whole idea here is to look at these cubes. There's a pattern that's growing. And one of the things that we could do is group students together, maybe have them work individually for a few minutes, and then they'll work with a partner, and then they'll begin to expand out their conversation. Is first describe a pattern you see in the cube buildings. Now, if we were doing this we would walk through this together as a group, and I would talk about all the details of it. But here I'm just trying to illustrate my point. Use your pattern to write an expression. Use your expression. So you notice that we're stepping out the problem. There's not one way to solve this. And it's an opportunity for students to explain their reasoning to someone else. And you would be shocked at how many different ways there are to solve this sort of problem and how creative students can be. There's been many times that students have surprised me with what their solution methods were because my brain just didn't think about it that way, but they did. And it's really, really powerful. So here is an example. I'm going to show just a very, very quick video of that very problem being worked out. I'm not going to show the whole 5 minutes because of time constraints, but this gives you an idea.
Come up and present what they came up with. Arden, come on. Now remember, one person speaks because we can't hear many people speaking at once.
Okay, everybody, like, on the thing there were arms, right? Which are the extended parts, right? So our pattern was that every time you add a cube to each arm, the total volume increases by 5 cubic centimeters, which I think was 5 cubes, whatever you want to call it. And then our equation was that 5n plus 1 equals the volume, and n equals the length of one individual arm. So that, like, this is the middle cube, excluding the middle cube. You would multiply that by 5 because there are 5 arms, and then add 1 for the middle cube, and that'll give you the volume in our number of cubes.
And for the third question, it was what's the volume of the 5th stage? Well, for the 5th stage, there'll be 4 cubes on each arm, so the equation will be 5 times 4 plus 1 equals the volume. So 5 times 4 is 20, plus 1 is 21, so the volume will be 21.
Yeah.
Okay, I'm going to go ahead and stop it there. But one of the things I hope you noticed there is that the student on the left, as he was speaking, he was realizing that what he was saying, he needed to clarify. So, I mean, he's thinking very quickly about, okay, how am I explaining this? Is this making sense as I'm saying it? Because it made sense to him, or it made sense to he and his partner, but it may not make sense to everybody else as I'm explaining it. So this is a valuable opportunity for students to explain their reasoning to a larger group. Now, if you watch the rest of the video, other groups come up and they solve this problem in different ways. And of course, that's incredibly valuable as well. But giving students an opportunity to share their thinking is very important. We talked about promoting active listening, right? Restating what a person before you said, explaining how your idea connects with what's already been said, summarizing what's been said thus far. Students can't do any one of these if they're not actively listening. And again, this comes from modeling, this comes from prompting. If there's one thing that teachers do, probably more than any other person on the planet, it's repeat themselves, right? If there's one thing that teachers do more than any other person on the planet, it's repeat themselves, right? So here, you have to constantly scaffold, constantly remind, but it's providing students with a reminder, I need to be paying attention here because I'm going to have to respond meaningfully. These are 5 tips for you to think about for productive math discussions. This is really from the preparation side. Number 1 is anticipating, right? So when you're putting together a problem, you're thinking about, okay, how are my students going to approach this? What are some mistakes that I've seen in the past that I'm pretty sure they're going to make? So think about, and then build questions that hinge on those particular areas of potential cognitive demand. You're monitoring, right? Somebody talked about formative assessment. So we're observing students' actual responses. We're adjusting maybe some of the questioning that you're doing. Maybe you're spending a little less time, a little bit more time, depending on what you're seeing and hearing in the conversation. We're selecting particular students to present their work. Of course, we want the student to be comfortable with sharing their work. But if you see, okay, I see that these 3 students have 3 key things that they're doing, I want them to share that with the class. You as the teacher, as the one who both knows the students and an expert in the content, are prepared and ready to do that. Sequencing, right? So we want to make sure that we're sequencing these conversations the appropriate way. So when students respond to our first set of questions, it's priming the pump for that next set of questions that's coming. So we have to be cognizant, okay, I'm not just, maybe I'm not handing them a worksheet or a packet and say, here you go. Maybe I'm giving them step 1 and step 2 because, I don't know, when I was in school, one of the things my teachers did with the overhead projector is that they would have a piece of paper over the transparency and they would very slowly, bring it down and reveal all the information, right? And I just take the paper off. Sometimes we do that, right? We want to mete out that information in a way that gives time students to think. We also want students to connect their different responses to other key math ideas, right? So we're structuring questions that are connecting these ideas to maybe ideas that we've talked about before or ideas that are coming up. Okay, so I can't really spend too much time here. We're kind of running short on time, but this is really just a metric for you to reflect upon your own teaching. Where are you in the level of discourse that's happening in your classroom? So the teacher is asking questions and affirming the accuracy of answers. That's really very low level. Mid-level might be asking open-ended questions to elicit student thinking. This is just a way for you to measure where you think you are, and for really just a tool for your reflection. I'm going to skip over a couple slides here because I want to talk about, I want to just touch on this quickly. We'll talk about building number fluency. One of the things that has a tendency to happen is we do time tests for fluency, right? I'm not saying time tests are bad, but we have to think about in context of a larger cognitive process that students do mathematically. Doing time tests is probably not the only way to address math fluency, and I would argue probably not the most effective. If you're familiar with the idea of number talks, it's the idea of doing mental mathematics and then explaining what I did. So if we were here together in person, this is a day-long thing, we'd work through this in detail. One of the things I would say, okay, multiply 18 times 5, and I want you to do it in your head. And then I want you to draw a picture of what you did. And then I want you to explain to someone else what you did. These are the types of practices that build number fluency. These are the types of practices that get students to really begin to become more comfortable with numbers because they work more with them. Very similar to exercising your body, right? I mean, if you do exercises, you build and develop muscle groups and those sorts of things. This is no different. I'm going to skip over. That's a funny video. You can watch that later. Okay, so one of the things when we're talking about selecting a math task, we want to choose the right task, right? Something that's open, that's aligned to my goals, that's aligned to the standards. We're asking good questions. We're anticipating those answers. We're creating open-ended questions, and we want to make that thinking public. And we want to monitor groups as they work. Are students just blowing through it so quick, like they got this? Are they really, really struggling? Or are they somewhere in between? So we're staying on top of that because we don't want students to get to the point of frustration. We want them to have cognitive demand. We want them to have some cognitive dissonance even, but we don't want them to become frustrated. And so you're monitoring their groups as they work to prevent it from getting to that stage. And of course, we talked about accountability. Okay, so I'm going to skip ahead here just because of time. I want to make sure. Okay, so here are some ideas for developing some math discourse. One of the things, we don't approach math like we approach teaching language sometimes. And one of the reasons for that is that students don't know how to talk math. They simply don't have the vocabulary. They don't necessarily, or they may not have the academic discussion skills. Maybe the math they're fine on, but they don't know how to interact in an academic way. So for example, you may want to post in your classroom, whether it's on your Google Classroom or brick and mortar classroom, posting these sentence starters. That if you want to share your ideas, start your sentence out with one of these three things. Now, as students become more comfortable with them, you can start to switch them out or you can add to them. That's entirely up to you. The idea is we're providing stems for them to begin that conversation. Well, I was thinking that, or I can justify my reasoning by, or how to respond to someone else. Sometimes students don't know how to respond to each other, right? Or they want to, it comes from a good place, but the student who's receiving that response is like, hey, you just insulted me. So if we talk about setting those norms, we can give some sentence stems, right? Could you be more specific about, or I solved it differently by, or I agree because, or I disagree because. One thing that students have a really hard time with is changing their minds. I think adults have problems changing their minds too. And how do you say that? How do you admit out loud that you were wrong and now you think differently? So there are some ways we can kind of grease the skids a little bit and say, okay, well, now I'm starting to think, or this reminds me of, or now that I heard this, I'm starting to change my thinking. Or I'm still wondering. I still don't know. I'm going to show this video. I think it's a pretty effective video to give you a sense as far as what we're talking about.
Talk moves are a way to encourage discourse in the classroom. And the first talk move that I learned was repeating.
That plus that. is 80. It's not 20.
Can you explain, Romy, what she just did up there?
What she said was 80 divided by 4 is not 20, so it's not going to be the same as those two, because when you add them up, it's going to be 80.
At first, no one can repeat it because children were used to, the teacher called on that person, so I'm going to check out until she calls on me. And then suddenly it was like, whoa, we need to pay attention. And they really started paying attention to each other, and they could finally repeat.
I would like to add something with Jason when Jason said 60, 80.
Another talk move is adding on, where they would listen very carefully to what somebody said, and then they felt that something else needed to be added. So they would say, I'd like to add on to what so-and-so said. Who has an answer that they want to give? Jason?
40.
And why do you think, are there any other answers? One of the talk moves that we created is the silent signal in the classroom that I'm thinking the same thing as you are. In my class, the I agree with you sign is this. It's like you and I think alike. That is so encouraging to the student who is speaking when they suddenly see everybody doing this to them. They're like, yeah, everybody's thinking the way I am, I rock. And they are encouraged by what they're saying.
You can't change the divisor, you can only change the dividend.
So what do you think, Jason, about what she said? She said revising our thinking is permission to change our mind once we are confronted with new information.
I think she might be right, so I'm starting to think it's false.
So you're starting to wonder. That talk move is valuable not just in math, but it's so valuable everywhere that when you're confronted with new information, you should change your thinking. You should take what you learn, merge it with what you already know, and then come to a new understanding that it's okay and that it's expected.
Okay, so I thought that video was particularly powerful at demonstrating what some of these ideas that we're talking about. Now, this is a 4th grade classroom, so things, excuse me, things might look different at different grade levels. And someone in the chat mentioned that hand sign is sign language to represent saying, which is awesome, which really kind of makes sense given what they're using it for. So a couple of these, I'm just going to throw out some resources here. Because we are running short on time, maybe in a middle school or a high school, this could be effective. This is a resource from the New York Times. I have it linked to here on the previous page. This is a link, so when I send this slide deck to you, you can click on it. This is a free resource the New York Times produces, and it's done like every week, I think, or maybe a couple times a week, where they provide graphs like these with very little information. And this is designed to elicit that conversation. What's going on in this graph? What is this graph showing you? What is this graph labeling? What conclusions can you come to? What more information would you like? So those sorts of ideas. And this is accessible to both your highest achieving student and your lowest achieving student. Everybody can look at this picture and have some idea about what's going on. And they provide more questions. They provide some resources to go along. Here's another one that talks about vaping, right? So they're very timely, they're relevant, they're things that students are dealing with. Probably more so for the middle school and the high school age group than the primary, but you find some that would be effective. That's really open, and it's all free, but for something to check out. So this video, we just don't have the time for me to show you, but I will talk about some of the elements. It has to do with providing those sentence stems. So this is an ELL classroom in a high school, getting students to interact with each other in a math way. And what she does is she provides sentence stems. And I have a resource for you later here that has a handout that you can download and certainly take a look at. But it's providing those scaffolds for students to have that conversation. We simply don't have the time for this either. I think I packed too much in here. Again, I'm taking a whole day and reducing it to an hour. But these certainly something you can take a look at when we're finished here. It's all about vocabulary and the importance of defining vocabulary. Judy mentioned in the chat, can I give a link to the video? Yes, when I send you the slide deck, the link is on the slide. So you can click on that and check that out. So one of the things that I would encourage you to think about is how we're teaching vocabulary, but I just don't have the time for that now. I want to get to, I'm going to fast forward here. just these resources. I want to make sure I talk about them. So vocabulary is super important. We do a whole different session in the fall coming up on vocabulary. It's really important, especially in the math classroom, some strategies there. Well, I also have a session coming up, shameless plug, in the fall called Disciplinary Literacy, where we've talked about math literacy. And we focus exclusively on math and how these things appear in the math classroom. These are some resources. These are some websites that have lots of really great tasks for students to work on. They're open-ended. Like I said, these are all links. So when I send you the slide deck, you can click on them and check them out. Plenty of opportunity. I'll just highlight just a couple of them. NCTM has some great ones. They do have a membership fee. There's a lot that's free, but if you want access to everything, there is a membership fee. ucubed.org is great. That is Dr. Bowler out of Stanford. She does a lot with math education, has this whole website built around math discourse and getting students to think about math deeply. Some really cool activities that are aligned to the standards. I'm not going to sit here and give you a bunch of things that don't have anything to do with the standards or what you should be teaching. This is to go and augment what you're doing in a meaningful way, not replace what you're doing. So this is something that I want you to think about. Also, Dan Meyer, he has a really great TED Talk, but he now works at Desmos. I don't know if you're familiar with Desmos. If you've used Desmos, it's a virtual calculator. It's the same company that does the one for the air assessment. They have a much more powerful calculator that's all free. But his blog has a lot of great questions, a lot of great tasks, and they're open-ended, and you spend time developing the questions. So some really great things there as well. Also, I'll point out this book. I don't work for NCTM. I don't gain anything by telling you about this. A lot of the resources that I pulled for you today are here. You can check out this book. It's like $20. It's a really great, it goes into those 5 practices that we talked about in a lot more detail and gives you a lot of examples and ways to get you started. So that's something you can check out if you're interested. So with that being said, I want to thank you for your time spending with us today. I'm sorry that we ran short on time. I get kind of long-winded sometimes, but I want to make sure that we talk about what we need to talk about. Again, I just appreciate you joining us today. I will stick around if you're interested in questions or further discussion. With that being said, I'm just going to draw an end to our time together now. So if you'd like to leave, you can certainly do that. Thank you and have a terrific day.